Hi, I'm Matt O'Malia of Geologic, and we're here at the Geologic prototype doing a very important test today. We've built the house very specifically and carefully to make it airtight as possible, cutting out all the infiltration, the leaks around the windows, the leaks in the walls and the roof, everywhere, trying to eliminate every leak. We've based the construction system on eliminating leaks to make it an airtight volume. The reason we do that is if we can eliminate those leaks, we can save a ton of energy for one thing. And the second thing is it's a very healthy indoor air environment because you don't have the mold and unintended air infiltrating, creating condensation and other things in the walls. What we have to pair that with, of course, is a ventilation system that's always running, providing fresh air into the house, keeping a healthy indoor air environment. So paired with a ventilation system in a very tight building shell or a shell that doesn't leak air, you can save a lot of energy and make a very healthy indoor environment. Okay. So today we're going to do a blower door test on the house, and that's a test that's been developed in the last 10 years which will verify how much air is leaking into the building. It's conducted by inserting a fabric panel in the front door with a fan. That fan blows air out of the house, depressurizing the house, which creates an inflow of air from all the shell of the building from the exterior, through the windows, through the walls, through the foundation. Now this test is an important one for passive house. Passive house requires that we have an extremely low infiltration number, as it's called. The number is so low that it's rarely reached in standard construction, if at all. To give you an example, in standard construction, 500 to 1,000 to 1,500 CFM is typical, which is a hole about, bearing about this size of a building. So if you take the whole shell and you add up all the little leaks, it's about this big of a hole, almost like an open window of air moving in through the building when we conduct this test. Passive house requires a hole about this big. As you can see, it's much, much smaller. Now, the test that we're doing today is going to verify whether we have a hole this big in our shell, cumulatively, or we have a hole this big, ideally even smaller. The test we're doing today is preliminary. As you can see, we don't have the sheetrock on the walls yet. That's the next step. And when we add finishes, it's very difficult to go back and conduct air sealing. So today we want to make sure that we're in the range of passive house to verify our performance, because once the finishes are on, it's almost impossible for us to then go back and fine-tune the shell. Another opportunity we have today is to actually walk around the building with the home energy auditors with their thermal imaging camera. What we get to do there is, on the video screen of the camera, see the actual surface temperatures of the walls, the windows, the floor and foundation in this case, and also the ceiling. What we're looking for is homogeneous orange, red colors, which mean nice, consistent, warm surface temperature all over. That means the wall's performing well. There's no cold bridges coming in from the outside to the inside. It's just completely warm and isolated from the exterior. At the windows, of course, there's always thermal bridging or cold transfer because the insulation values are less. But that's acceptable, of course, and that's why we've always designed the windows and their area in the building shell to perform with this climate. But what we're pleased to see today is that the walls look great, they're nice and orange and consistent, and that means that we've done a very good job in building a well-insulated house that just is going to perform as we expected it to. So today was a really important test day for us to verify how well we've been doing building this building from the ground up. The key to what we're trying to do here is build a super energy efficient house. And with the blower door testing and the thermal imaging camera, we've verified that we've done an excellent job. The numbers that we're seeing today are below what we expected to see, which when we put back into our energy models and look at the long-term performance of the building is great, because we know that this building is going to perform as it was designed to, and in doing so save an enormous amount of energy over its lifetime.